All right, everyone. This is homework number 3 for chapter 5, number 66. Determine whether 447 is a term for each of the sequence below. And if so, which term is it? So notice how all of these are written in the explicit form, like how we talked about in class. And if we want to know if 447 is a term, like is it term 20 or 21 or 500 or 501 or 502, right? Then we got to make 447. We're going to make 447 into the term itself. So instead of saying t of n, we want to say 447 equals 5n minus 3. And we got to do that for each of these, right? So I'm going to go ahead and substitute 447 into each of these. So I'm going to start with 447. Here, I'll do it. I'll get rid of that 447, or excuse me, I'll get rid of that t of n. So for part A, I'm going to write down 447. And then I'm going to see if it comes out to be a real number, right? So to solve this, I'm going to have to go and add 3, both sides. Okay. And 447 plus 3 makes 450. And these cancel, so that's going to equal 5n. I'm going to go ahead and divide both sides by 5. And these cancel. And if you need, use a calculator, like me. Okay, so I'm going to go ahead and do 450 divided by 5. And if you know your times table, you know that it does go evenly. And I don't know how many times, but the calculator tells me 90 times. So n equals 90, which means that the 90th term is going to be, it's going to come out to be 447. Okay, so for A, it's going to be the 90th term. Okay, we'll do B. So again, I'm going to go ahead and do on B, I'm going to put 447 into the T of n. So I'll use blue in this one. 447. Then I'm going to work it out. So in this case, I'm going to go ahead and minus 24. Minus 24. And if you need a calculator, use it. Okay, so that you got 447 minus 24. That makes 423. So we have 423 equals negative 5n, because that's all we got left on the right-hand side. Okay, we're going to divide both sides by negative 5. And these cancel, and I'll be left with n equals, so it's 423 divided by negative 5. So I got 423. I'm going to divide that by negative 5. And if you know your times table, 5 doesn't go into anything that ends in a 3. So you see how it's negative 84.6? So which means that it does not go in evenly. So this one, right? What was it again? Negative 84.6. So negative 84.6. So this one would be 447, not a term. Excuse me. Okay. On letter C, I'm going to get rid of that T. Oops, I meant to touch white. Okay. So on letter C, I'm going to get rid of that T of n, and I'm going to put in 447. I'm going to use green for this. So 447. Okay. Still dying out here, guys. Okay, in this case, I'm going to go ahead and add 6. So 447 plus 6. Okay, that's 453. So we get, I'm going to do it on the side over here. In green, 453. That's going to equal, and this right here, I'm going to go ahead and distribute the 3 in, and then the 3 to the negative 1. So that's going to give me, so these cancel, so I'm going to be left with 3 in, and then 3 times negative 1 is negative 3. Okay, then I'm going to finish off by adding 3, which makes 400. These cancel. 456 equals 3n. Then I'm going to go ahead and really finish it off by dividing both sides by 3. That way that these right here cancels. And we get n equals, and we'll see what happens. So 456 divided by 3. 456 divided by 3. And if it goes in evenly, that means that it's the 152nd term, right? So n equals 152. So this is the, so it does go, 447 is the term, and it is the 152nd term. While we're at it, let's do C because, or E, because it's on the same side. So I'm going to go ahead and use purple for this. Right? So purple on E. So I'm going to go ahead again, put 447 in the place of the T of N. 447. And I'm going to go ahead and continue solving this. So I'm going to go ahead and add 8. Remember, we're doing opposite when we're trying to solve. These cancel. So 447, clear that out, plus 8 makes 455 equals. Now I'm going to go ahead and distribute this negative 7 to the n, which makes negative 7n, and negative 7 to the negative 1, which makes positive 7. Okay, hopefully you've been thinking about that already, so you're not confused about what I did. Okay, and that is a negative 7. I was just double checking it. Okay, I'm going to go ahead and minus 7, because that's the opposite of a positive 7, which means I have to do minus 7 on this side also. Right, so on my calculator, so 455, which is what I have, I'm going to go minus 7, which makes 448 equals negative 7n. Okay, and most likely because it's a negative, that means that it's a term that comes before the 0th term. Okay, if it does go in evenly, which most likely it's not. Okay, so 448, I'm going to divide it by 7, or actually negative 7. Oh, it actually does. Well, surprise to me. So if I divide by negative 7, n equals negative 64. At least that's what I thought it was. Let me see. Yep. So that means that this is the negative 64th term. So you know how we have the first term, second term, and then we go backwards, we have the 0th term? Well, there's the negative 1 term, the term before the 0, the negative 2 term, the term before the negative 1, and then we go all the way back to negative 64. So this is actually a term. Okay, and last one. Who wants a color? Who wants to pick a color? Come on, gotta hear somebody. Just kidding. Can't hear anyone. I'm doing this by myself. I'm lonely. All right, so I'm going to go ahead and get rid of that D in the T of N, which is the term. Okay, and then I'm going to go ahead and pick my orange. So I'm going to use 447. Okay, and that's going to equal that. So I will have minus 14, cancel. So again, I'm going to start one more time. 447 minus 14, that gives me 433 equals a negative 3n. Then we're going to divide by negative 3. Cancel, and we get n equals, and again, if it goes evenly, then we got something. We're not. So 443, I'm going to divide that by negative 3. That gets me negative 144.333. Line over it, which means 447 is not a term. Okay. Okay. And I believe this is, oh, there's 2 more. Number 67. And number 68. Choose one of the sequences, and 566 for you, which you determine 447 is not a term. Oh, this one's easy, right? Sorry, runny nose. Write a clear explanation describing how you can be sure 447 is not a term in the sequence. Right, so either B or the last one. So I'll go with either one. It doesn't matter. We'll go with the blue one. So I think that was B. So I will say for here. I'll lowercase it. I'm not trying to be formal or anything anymore. So for sequence B, I'll put that in that. For sequence B, 447 is not a term because when I solve for n, I get negative 84.6. Okay, this means that 447 is the term in between negative 84 and negative 85. Okay, so that's what I'm going to say. Because negative 84.6 is not quite negative 84 and not quite negative 85. It's in between, which means that to get 447, it has to be in between negative 84 and negative 85. Okay, last one. Okay, determine the common difference, the sequence generator for each arithmetic sequence listed below. Then write the equation for the nth term of the sequence. And this is what we learned today. So hopefully you guys do not need help with this and you're just using this to check your answer. Don't be lame. Try it out first. Don't watch the video until you tried it out and you've not succeeded, or until you've succeeded and you want to check your answer. Okay? So pause it here if you haven't done it yet. Okay? I'm going to go ahead and do this. So A, we have from 4 to 7 is plus 3. 7 to 10 is plus 3. So I know it's the sequence generator. 10 to 13 is plus 3. So I know that our common difference, right, our D equals 3, or you can say positive 3. Our equation is T of n equals, because if we're going up by 3, that means that as many times as you want to get it, we have to multiply by 3. So it'd be 3n, and then we got to figure out what the 0th term is. And in this case, this is our first term, second term, third term. So we need to find the 0th term, which means we got to go backwards. So instead of adding 3, we need to go backwards. We need to subtract 3 from the 4. So 4 subtract 3 gives you 1. Right? So the 0th term is 1, and that's what we're going to add to this. And that's our explicit formula. Let me see. Then write the equation for the nth term in each sequence. Keep in mind that the first term in each sequence is T1. Yeah. Okay. So now this is the explicit. If you want to write in a recursive, you can write it. I'll put it in orange, and I'll only do this one. Okay. So you can write it in orange. You can write it as, first you can start with, okay, well, T1, oh, why am I doing that? Okay, so you can write as, okay, T1 is 4. Okay, this guy right here. And then now you can say, okay, I need the next one. So the next one is T of n plus 1 is equal to T of n, right, which is the one before the n plus 1. And then it's going to be plus 3 right there. So it's just, how do I get the next one? I'm going to have to take the previous one and add 3. So you can either have this explicit equation right here, which is really awesome because you can go anywhere you want over that. Or you can go with this recursive equation, recursive formula, which it requires 2 parts. Okay. Mainly it's just this part. But because you don't know what to start with, you got to have a sentence generator or a sequence generator, which is that part. Okay. So you can do one or the other. I'm going to lean on the explicit formula, the one that we haven't read. Okay. So I'm just going to stick with that. And I'm going to erase the recursive because it's a little tedious. Okay. So moving on. Go green. This one is from 3 to 8 is plus 5. 8 to 13 is plus 5. So I think I have my sequence generator, which is the common difference of 5. So now I know my explicit equation, T of n equals 5n. That's how you start it. As soon as you find the sequence generator, you have the first part of your explicit formula. Okay, all you need to do is go backwards. So instead of plus 5, you're going to go minus 5 from the 3. So 3 minus 5 gets you negative 2. So that is your 0th term. So my explicit formula, T of n equals 5n minus 2. We can put plus negative 2, but to simplify it down, it's going to be T of n equals 5n minus 2. Okay, blue. Okay, so this one, from 24 to 19, it looks like, let's see, 19. And I think I show first period of this, but if you want to know what's going on and if it's an arithmetic sequence, you take the second number, 19, and you subtract the first number, 24, and that gets you negative 5. Right? So what's happening is from 24 to 19, I'm doing negative 5. Where is it now? Okay. Now, you want to double check, make sure that's the same pattern. So you're going to take the third number, 14, and you're going to take away the second number. So the previous one or the next one minus the previous one. So 14 minus 19. And if it keeps the same pattern, negative 5, then we know that this is the sequence generator of minus 5 every time. So our D, excuse me, allergies, I guess, our sequence generator, our common difference is D equals negative 5. And as soon as we know that, we know our explicit equation is T of n equals negative 5n. And then we just got to figure out what the previous term is. And to go backwards, instead of minus 5, we're going to go the opposite, which is plus 5. So 24 plus 5 gets you 29. That is the previous term, or the n, or the 0th term. So we're going to go and do negative 5n plus 29. That is our explicit formula. Okay, last one. I'll do this in purple. So from 7 to 9, again, use a calculator. Okay, most of you guys can probably do this in your head, but let's just say, I'm not too good. So I'm going to go 9.5, take away 7, get you 2.5. And I'm going to double check. So I'm going to use the next number, 12. I'm going to take away 9.5. And it looks like it's the same thing, 2.5. So it looks like I'm doing positive 2.5 every time. So our D is equal to 2.5, which means that our T of n, our explicit formula, starts with 2.5 n, and then we got to figure out what the previous number is. So I'm adding 2.5, then if I want to go to my previous number, I have to subtract 2.5. So 7 minus 2.5, and use a calculator if you need to. So 7 minus 2.5 will give me 4.5, and that would be my previous number, or my 0th term. So 4.5 is my 0th term, and that is what I need to add onto my explicit formula. Okay, that's a wrap, guys. See you